Assalamu alaikum wa rahmatullah, my dear students. Welcome to this lab of IPv6 series. In this lab we are going to configure the RIPng routing protocol in the topology that we have configured in the previous lessons. Okay, we need first to recall the link local addresses for the routers, because the link local addresses will be used by the RIPng routing protocols to exchange the necessary messages. So we will show IPv6 interface, a brief, just to recall the link local address for each router. Here we have FE80::, for router 1, and for router 2 we have FE80::2, for router 3 we have 80::3, and for the ISP router, which is the fourth router, as you remember we have 4 routers, the link local address is FE80::, FEED. Okay, now let us start the configuration. We will configure the RIPng routing process using the global configuration mode. So config terminal. Okay, now we will enable the RIPng process by using IPv6 router RIP and specify the RIPng process name. Okay, now the RIPng routing protocol is enabled, and the process name is RIPng, all capital letters. So exit to finish the configuration. Okay, this name identifies the specific routing process. It is used to identify uniquely the RIPng process on the local router. The name is case sensitive, and it does not have to be the same on all routers in RIPng routing domain, but for operational purposes it is good practice to have same RIPng process name on all routers. So we are going to use the same RIPng process name, which is RIPng, capital letters, in all routers. This will make the configuration monitoring process easy. Okay, the next step is to configure the RIPng routing process using the same process on the interfaces. Okay, we are going to use the same name, which is RIPng, all capital. So let us go to inside the RIPng mode. RIPng, this is the name. Okay, now for the interface 00. Okay, we will enable the RIPng process. So IPv6 RIP, then specify the process, which is RIPng, all capital, then enable. Okay, now the on this interface, which is Ethernet or fast Ethernet 00 of router 1, yes, this interface, the RIPng process is enabled. We will repeat the same command for the rest of interfaces. First with S00, the same command. Then for next is S01, the same command. And for loopback interface, loopback 0, we will use the same command and end. Now the RIPng is enabled. First we enabled it at the global configuration, then we go inside the RIPng configuration mode and we enable the RIPng using the same process name, which is RIPng all capital for each interface. Okay, now we will do the same in router 2, but I'm going to copy and paste the command. This is for router 2. Okay, very good. And for router 3, yes, okay, very good. Before we complete the configuration in router 4, which is ISP router, we have to notice that the interface S10, this interface S10, we didn't configure the RIPng because this interface will be used for the default route to the ISP router. Configure only for fast Ethernet 00, serial 00, serial 01, and serial 10 we did not configure because this interface will be used for the default route to the ISP router. Okay, again we use the same RIPng process name, which is RIPng all capital letter. As we said, this is good practice and it will make the maintenance and monitoring processes easy. Okay, now we need to enable the RIPng ISP router, but before that we need to configure the default route in R3 router. So let us do it now. I'm going to enlarge this. Yes, configure terminal. Then we use the IPv6 default route, which is : /0, and we will pass any packet which is directed to any interface not listed in the routing table to this interface. Sorry, we have to use root. Yes, now the default route or default route is configured. Now we need to issue this command. I will do it and then try to explain it. Interface fast Ethernet 00 then IPv6 RIPng, this is the process name, default information originate. Okay, I will repeat the same for the other interfaces. 000 and serial 01, the same command, which is IPv6 RIPng, the process name, default information originate. Okay, end. Okay, this command is configured on 3 of the interfaces on the router 3 by using default information. This the default router will be originated to the routers on the domain. Okay, so each router 1, router 2 will get the default router number, actually, which is : /0 from this router, actually by using the RIPng protocol. We are going to go to ISP router and do the configuration. Of course, we will not use the RIPng because it is point-to-point link, so we are going to configure static route between the ISP router, this router, and the third router, which is R3 router. So configure terminal and IPv6 route. You should remember this command: 2001 db8 2001, then : /48. This is the global interface for the topology, and this global prefix will be directed through the S00 yes interface on the ISP router. End. Okay, now we want to verify the configuration after completing the RIPng configuration for all routers. First, we will use show IPv6 protocol. We will make the configuration on router 2 only, just to see the output. The show IPv6 protocol command is used to display the parameters and the current state of all active IPv6 routing protocol process. By default, connected and static IPv6 routing is active. This has these two routing protocols are activated when we issued IPv6 unicast routing command. The output on router 2 also shows that the RIPng, which is named as RIPng all capital, is active for all interfaces, for loopback 0, for serial 01, serial 00, and for fast Ethernet 00. Another command that we can use to verify the configuration is IPv6. Show IPv6 for a specific interface. So interface fast 00. Okay, this verifies that router 2 fast 00 fast Ethernet 00 interface is now a member of RIPng multicast group, this multicast group, which is FF02::9. RIPng use this multicast group as the destination address for RIP update messages. Okay. Now the third command is show IPv6 root RIP. As you know, you should remember this command. We used it in the static routing configuration. This command shows the routing table entries. We need to notice that this default route, which is : /0 that we have configured on router R3 has been distributed to router 2 through the RIPng protocol. R indicates RIPng as a protocol that derives the root. Here we have the prefix and prefix length, and here we have the administrative distance, and the second number, which is 2 here, indicates the metric, the metric of the root. Notice that the number of hubs, or the metrics of the root, this is 2. Of course, it can be said that this is the number of hubs. Unlike in IPv4, the Cisco implementation of RIPng, in IPv6 increments the metric by 1 when receiving the routing update from a neighbor. Okay, and this is via the link local address of the router. Okay, now we can use also the ping command, our friend command. We are now in here, so let us ping this address, which is this address, which is 2001:DB8:FE00:1:/2. I will ping this interface. Sorry, :2, not /2. Yes, all success. Let us also ping this address, this interface. So ping 2001:DB8:2001 is yes, :3::1. This interface. Okay, success rate is 100%. Everything is going right. Now, of course, we can use also show IPv6 RIP. This is the same in IPv4. The output, of this command is the same in IPv4, but we have to notice that, for example, some references Yes, here in IPv6 the port number used is 521, which is UDP port, but in IPv4, as you remember, in RIPv2 actually, which is for IPv4, the port number is 520. Yes. One of the most important notes that we have to notice is in the Cisco iOS software implementation of RIPng, each IPv6 RIP process maintains a local routing table called Routing Information Base RIP. RIPng tries to insert every non-expired route from its local database into the master IPv6 routing information base, also known as the IPv6 routing table. So we have local database and we have master IPv6 routing table. If a router learns a multiple routes to the same network, RIPng stores only the lowest cost route in the local RIPng RIP. And also, if the same route has been learned from one routing source with a better administrative distance than RIPng, the RIP route will not be added to the IPv6 routing table, but it will exist in the RIPng RIP. To show the database, the local database, you can use show IPv6 RIP database command. Here you can see that we have, for example, in this route entry is installed and it will expire in 156 seconds, and this will be expired in 174 seconds, and so on. Okay, if you want to see the next hop only, you can issue show IPv6 RIP next hub command, hubs command actually. Yes, here we are in router 2 R2, and this, as you remember, has the link local address which is FE8::2, but if we want to reach this router, which is router 1 R1, there are 4 paths, and if we want to reach router 3, we have to go to serial 0, 1, and we have 5 paths. Okay, that is good. The last command that we can use to delete the RIPng process, you have to go to global configuration terminal, global configuration, and issue no IPv6 RIPng enable. That's all. We need to, yes, we need to delete this one. No IPv6 router RIPng. This will this command will, which is, as you see, as a global configuration command, will remove the RIPng process, including any interface configuration commands used by that process. So you will delete everything, you will disable everything, you will remove the configuration that you have completed previously. Okay, that's all for this lab. Thank you very much, and see you in the next lab.